Welcome to lesson 6.3, solve systems of linear equations using substitution. So in the past, we've talked about solving linear equations graphically, but now we're going to use an algebraic way, and there are two algebraic ways, and today we're going to learn about the substitution one. So if we look down to our objective for today, it says I can solve systems of equations using substitution. So it is sometimes difficult to determine the exact solution from a graph. An algebraic method may be used to find the exact solution, right? Let's say the solution to the two equations where they intersect is 0.34 as your x value and 0.6 as your y. That's really hard to look at with a graph. So we use this method called substitution, which is an algebraic way of doing it. So what does substitution mean? Well, substitution means that when we solve one equation for a variable, right? Variable being either x or y, and we plug it into the second equation. So we isolate one variable, and then we take that variable and what it equals, and we put it in place in the next equation, okay? So what I want you to do is flip the page for me. And we're going to explore some of this and compare it with the graphic version first. So it says solve a system of equations using the slope formula. So this should be nothing new. Let's take a look here. Our first one, they're both in y equals mx plus b form. Our first one is y equals x plus 1. That means my y-intercept is 1, so I mark 1 right here. My slope is also 1. It's in front of the x. So you're going to go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. And then I'm going to graph this. Now, if we notice here, the slopes are different, right? I have a 2 and a 1. My y-intercepts are different, a 1 and a -3. So I should know that these are going to intersect and there will be a solution. Okay, so now look at the next one. We have a y-intercept of -3 because our b is -3. So we're going to mark -3. We're going to go up 2 over 1. So go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. What do we know? They intersect right here at the point 4, 5. So the solution to our two equations is the point 4, 5. All right, so let's take a look at solving this using substitution as our method. So here's what I want you to think about for a minute. Y equals x plus 1. But y also equals 2x minus 3. Right? Y equals two things. They're two different things, but really they equal one another because y equals both of them. Well, Miss Wall, that was a mouthful. All right, so think about it this way. If we were to write y equals x plus 1, right? But this y, if we ignore this over here, this y right here also equals 2x minus 3. So if we write y equals 2x minus 3, that's true. That's this part right here. So really, y equals x plus 1, but y also equals 2x minus 3. So what that really means is we can get rid of the y, because if this expression equals y, which equals this expression, it holds true that we have 2x minus 3 equals x plus 1, right? Y equals both of them, which means they have to be the same thing when solved, which means that they equal each other. Okay, so now what we can do is we can solve this to figure out what is x in our equation. So let's drop our line for our solution, right? Now, we have a couple of things going on. The first thing we have to do, remember, is to get rid of the x. So we're going to subtract x from both sides. Now we're left with x minus 3 equals 1. Our next step is to add 3 to both sides to get x by itself, so we have x equals 4. So what that's telling me is that these two lines have a solution when x is 4. So we know x is 4 now. We need to figure out the y value in our solution set. Right? And that's exactly what we got up here. We got y was 4. Or sorry, x was 4 as well. X was 4. So we have x is 4 here. We have x is 4 down here. Now we need to figure out what the y is. So what we're going to do is we're going to take our x value, just like we checked with our graphs, and we're going to plug it in to both equations to make sure that it checks and that we get the same y value. So here we have y equals x is 4 plus 1. Well, 4 plus 1 is 5. Here we have y equals 2 times 4, which is 8 minus 3, which is also 5. So we have that our y value is 5 and our x value is 4. So the solution is the 0.45. Okay? We can't just have an x value or y value as a solution. We need the entire point like we did with the graph. All right, so doing a little bit of recap here. Solution of two linear equations, right? If a system has one solution, like our example up here, then we know that they intersect at one point and that the xy value satisfies both equations. Right? If the system has no solutions, that means that the lines are parallel. That's a symbol for parallel. I'll write it out too. And we know that they have the same slope, but they have a different y-intercept. Right? Infinitely many solutions, they're the same exact line, which means they're going to have the same slope. They're going to have the same y-intercept. Everything's going to be the same about them. Okay? So when you're ready, please flip the page for me. All right, so looking at this next one, use substitution to solve the equations. So because it says we have to do substitution, that's the method that we are going to use. So if we look at the first one, we have that y equals 3x plus 6. But y also equals 4x. What that means here is that we can take 4x and we can substitute it in for this y. X is the same as y. So we could rewrite this equation as 4x, right? Because y equals 4x equals our 3x plus 6. All I did there is said, hey, well, y equals 4x. So wherever I see a y in my first equation, I can plug in 4x instead, because that's what y really equals. So now from here, it's super easy to solve for x. We drop our line. We have a 3x on this side. The opposite is to subtract 3x. We're left with 1x equals 6. So then, of course, we divide by 1. We get x equals 6. So that's our x value for our solution. But remember, it's a point, so we need our y value. So what that means is we're going to take our x value, plug it back in for x into each equation, and see what our y value is. So our first equation is y equals 4x. So y equals 4 times 6, which is 24. So that means when x is 6, y is 24. Our next one is y equals 3x plus 6. So y equals 3, our x value is 6 plus 6. Well, y equals 18 plus 6, which is 24 as well. So I know that for both equations, when x is 6, y is 24. So my point of intersection in my solution is the point 6, 24. Okay? Let's take a look at the next one. All right. Sorry, guys. All right, so this next one says 6x minus 2y equals -4. And y equals 3x plus 2. So we want to get this equation all in terms of x, one variable that we can solve, just like we did the last one. Because y equals 3x plus 2, wherever we see a y, we can replace it with 3x plus 2 because they're the same thing. So when we do this, we get 6x minus 2. Now y is being multiplied by that 2. So that means we need to put everything that y equals in parentheses because we want to make sure that that whole thing is being multiplied by 2. So all I did here is replace the y with 3x plus 2, and that equals -4. So now to solve this, I have to remember to distribute my negative first. So I have 2x, or 6x. -2 times 3 is -6x. -2 times 2 is -4 equals -4. Now I have 6x minus 6x, which is 0. So they cancel, so I'm left with -4 equals -4. But when this happens, remember, we have infinitely many solutions. So what does that mean? That means that they're the exact same line, right? If we were to solve this equation for y equals mx plus b form like we did the other day, we would see that we would get y equals 3x plus 2. Pretty cool, right? All right, let's take a look down here at this one. We have 8x plus 2y equals 13, and y equals -4x plus 11. So I want to get one equation in terms of one variable, either the x or the y. And because y is already by itself over here, it seems like the best course of action is to take what y equals, which is -4x plus 11, and plug it in for y in my first equation, because they're the same thing. So here I have 8x plus 2 times my y. Now y is the entire thing here. Y is -4x plus 11, and that equals 13. So now I have to distribute and combine like terms to solve. So here we have 8x, 2 times -4 is -8x, 2 times 11 is a positive 22, which equals 13. So now if I look here, 8x minus 8x, well, they're going to cancel. They're going to give me 0. So I'm left with 22 equals 13. When on earth does 22 equal 13? Never, right? So that means we have no solutions. But what does that look like when we graph it? Well, when we graph it, it means they're going to have the same slope, but the different y-intercepts, right? So if we were to solve this for y equals mx plus b, we would see that their slopes are both -4, but their y-intercepts are something else. Okay? All right, let's take a look at this next one together. We have y equals 3x, and we have x plus 2y equals -21. Again, we want to get one of the equations in terms of only one variable. So because y is equal to 3x, that means wherever I see a y in my second equation, I can put a 3x instead because they're the same thing. So we have x plus 2 times y becomes 3x equals -21. So when we solve this, we have x plus 2 times 3x is 6x equals -21. Now I need to combine like terms. X plus 6x is 7x equals -21. I'll have to divide by 7 to get 21, or x by itself. So we have x equals -21 divided by 7 is a -3. But be careful, -3 is not your answer, right? You need an ordered pair as your answer. You need a point as your answer. So what we have to do now is take our -3 and plug it into the equation to see what the y value is that matches it. But knowing that x is -3 helps us tremendously because we know that x equals -3 is a solution for both of these. So when we plug it in, we have y equals 3x. So we have y equals 3 times -3, which is a -9. Right? Because we know that y is -9 when x is -3 for the first one, let's take this pair and plug it into the second to make sure we get the same thing. So we had x plus 2y equals -21. That was our second equation. Our x, we're going to plug in -3, and for our y, we're going to plug in -9. And see what we get. So we have negative 3 plus negative 9 times 2 is negative 18 equals negative 21. What do you know? Negative 21 equals negative 21. So we know that that y value of negative 9 is absolutely true. So our point of intersection is negative 3, negative 9. Right, so that's the solution to our two equations. All right, now I'd like you to flip the page for me. Let's take a look at this page. Now there are 4 different problems on this page. What I would like you to do is take a moment and I want you to solve each and every one of them. All 4 of them I want you to do. Okay, if you have any questions at all, please do not hesitate to raise your hand. There's a lot going on. The main thing to remember is that wherever you see a y in one equation, you can substitute what that equals in for y in its place. Okay, so what I want you to do is work on these 4 equations. You're going to raise your hand to get them checked when you are done. And please, please, please let us know if you have any questions at all, okay?